Okay, so I want to take you through a few example problems that I see in your Choco's textbook that I think are really great. Okay, really nice to learn. You probably want to make cue cards of these examples. So let's talk about the first one after doing the roller coaster problems, which are pretty simple. Let's talk about problems that involve ramps. Okay, so if I have a ramp, okay, let's say it has a 30-degree incline, and I have a ball that is 1 kilogram on top of that ramp, all right? And let's say the vertical distance here is 10 meters, okay? And let's say there's a friction coefficient being 0.2 on that ramp. What if I asked you a question that asked you to calculate what the final velocity, so what is the final velocity of the ball after it rolls down the ramp? Okay, so how would we go about solving this problem using conservation of energy? Not other things. Like maybe this conservation of energy can allow us to solve this quicker. So the way of thinking this, I want you to pause it and just try this on your own before I walk you through the solution. But the way of thinking this is that the potential energy of the system is going to be converted into work and is going to be converted ultimately into kinetic energy. So how would I set up the conservation of energy problem? So the total energy before is equal to the total energy after. And in this case, it starts with only gravitational potential energy. So how would I set this up? So take pause, and when you unpause it, here we go. So in this system, I have gravitational potential energy being converted into kinetic energy plus work done against friction. All right, the work I do against friction is going to decrease the actual velocity of this object because some of that energy is going to be used up. All right, so how would I calculate the velocity in the end? That's what I'm trying to find. Velocity is only in my kinetic energy term, so I have to try to rearrange this equation. So let's put this together. So EP minus the work due to friction is going to be equal to my kinetic energy. So if I just erase that, that's what the total work, the total energy was potential energy converted into that. If I rearrange this equation, my gravitational potential energy minus the work that I did against friction is going to be my kinetic energy of that object at the bottom of the ramp. Okay, so then how do I start putting this together? Well, mgh, this is my vertical distance, which I've given you in the problem, minus, okay, so how do I calculate? Well, it's force, the frictional force. So the frictional force acting in that direction on that object for that total distance. Ooh, that's not easy. How do I calculate that total distance? I got an angle. I have that side. I could probably calculate that. Let's try to piece this together. So the work due to friction is going to be the force of friction times the distance it goes down the ramp, which is going to then equal to 1/2 mv squared. All right, so I gotta try to expand this. This is the hard part. I need to figure out force of friction. Okay, so mgh minus Fn times mu times d is equal to 1/2 mv squared. Got that. And on a ramp, I know what Fn is, so let's keep going. mgh minus mg cos theta, that's Fn, times mu. Now the distance, I'm going to calculate. This is my hypotenuse, that's opposite, so it looks like it's going to be a sine function. Looks like it's going to be a sine function. Opposite over hypotenuse. So sine theta is equal to opposite over hypotenuse. So to solve for my hypotenuse is going to be it's going to be 10 meters divided by a sine of 30. Okay, which I can already calculate in my head, but it'll be 10 meters divided by a sine of 30 is equal to 1/2 mv squared. All right, so let's take a look at what I can do here. Already, before I do any math, I can see something that I can simplify. I can get rid of the m's. I can factor out the m's. So the m's will cancel out. I don't have to worry about the mass of that object. Okay, which then leaves me with this. So g times h minus g cos 30 times 0.2 times 10 divided by sine of 30 is equal to 1/2 v squared. Okay, so in the end, my velocity is going to be equal to 2 times gh minus g cos 30 degrees times 0.2 times 10 over sine 30 square rooted. All right, and if I plug all that in, I will be able to calculate my final velocity of that object.